My name is Mackenzie Barr, and I'm a freshman exercise physiology student at West Virginia University. This school year, I have had the honor of assisting with research and studying how upper limb performance of stroke survivors is affected by functional electrical stimulation under the guidance of Dr. Grasenko and Ariel Thomas. Throughout my time working in the lab, I have developed a better understanding of how rehabilitative treatments affect the mobility and muscle activity of stroke survivors. My family was recently impacted by stroke, so I know firsthand the impact stroke rehabilitation research has on the daily lives of so many individuals. For example, each year over 795,000 people experience a stroke within the United States. When someone experiences a stroke, they often experience paralysis or loss of movement within the upper limb, which has a large impact on daily activities such as eating and getting dressed for the day. Due to these impairments and the large number of people affected, stroke is the leading cause of long-term disability. The loss of mobility and independence can be frustrating for stroke patients. One study found low functional status and higher severity of stroke is associated with lower quality of life within stroke patients. Along with paralysis, many stroke survivors experience spasticity, or the continuous contraction of muscles, which makes movement difficult and painful. A variety of rehabilitation techniques and assistive technologies are being studied in hopes to find more successful ways to improve functionality and the quality of life of stroke survivors. Functional electrical stimulation, or FES, is one example of a common stroke rehabilitation technique. FES is the artificial stimulation of the muscles that causes muscular contractions intended to produce or assist with movement. Although it has been used for decades as a rehabilitative treatment for stroke, the performance of the hand when using FES to assist with shoulder mobility is less clear. This study aims to determine if the use of FES on the shoulder improves upper limb performance for stroke survivors in a reach and grasp task. 4 stroke survivors and 20 control participants were recruited to complete a reach and grasp task within virtual reality, or VR, which can be seen in this video. First control trials in which participants reach and grasp at a ball seen in VR were conducted. 40 repetitions were completed in the forward direction, and another 40 repetitions were completed in the lateral direction. The ball changed colors to provide the participant with feedback on movement speed and encourage moderate but consistent speed of movement between the two targets. Next, experimental trials were conducted. Stimulation was slowly increased to determine the amplitude at which sufficient muscular contraction occurred. Sufficient muscular contraction was defined as 20 to 30 degrees of movement in the forward or lateral direction. Experimental trials were completed with this set amplitude. The participant then completed the reach and grasp task again in both directions with assistive stimulation. When movement was detected, FES was triggered to apply stimulation to the medial deltoid for the lateral task and to the anterior deltoid for the forward task. 80 total repetitions were completed in each direction with FES. Control trials were then repeated with an additional 40 repetitions in the forward and lateral directions. Throughout the reach and grasp task, data was collected using electromyography or a recording of electrical muscle activity, as well as motion capture of the trunk, arm, and hand. 2 of the stroke subjects had difficulties with spasticity. Grasping ability, muscle activity, and movement duration of these 2 subjects were analyzed in FES and non-FES conditions. This is a case-by-case analysis, so the following results cannot be applied to the overall stroke population. A larger sample of stroke survivors would need to be studied in the future to be able to apply findings to the overall population. The extensor digitorum and the flexor digitorum superficialis are 2 muscles that are responsible for grasping. Electromyography data of these 2 muscles are shown in Figure 2. Within each plot, the left set of data is from the forward task and the right set of data is from the lateral task. Control trial data is shown in blue and experimental trial data is shown in gold. Electromyography recordings showed decreased muscle activity or spasticity when assistive FES was used in stroke survivors. Grasping ability for the forward task can be seen in Figure 1. The same color coding system was used in these plots as well. Although muscle activity decreased with FES assistance, grasping ability of the stroke survivors was not affected. Movement duration can also be seen in Figure 2. When assisted by FES, the stroke survivors were able to complete the lateral task quicker than without FES assistance. However, the stroke survivors took longer to complete the forward task when assisted by FES. We suggest that assistive FES could be used to alleviate spasticity and increase the grasping mobility of stroke survivors. Future works could be conducted to develop a wearable device that would apply triggered FES to the shoulder of stroke survivors. Hopes for this device would include improving hand performance as well as addressing the low functional status and low quality of life in stroke survivors. Finally, thank you for taking the time to watch my presentation. I would also like to thank Dr. Krasinko and Ariel for giving me the opportunity to work with them this school year, as well as helping my understanding of stroke rehabilitation to grow.